Hello and welcome to this session, LO3, Implementing a Behavior-Driven Development (BDD) Process. Today, we will explore how BDD transforms software testing by aligning system behavior with business expectations, from concept through to practical execution. Behavior-driven development focuses on system behavior from a user perspective. It ensures everyone shares the same understanding of software functionality. BDD compares actual software behavior to expected outcomes. This approach reduces confusion and improves communication. It aligns testing with business requirements. BDD is supported by open-source frameworks like Cucumber. Cucumber allows writing tests in plain language. It connects these tests to automation code, enhancing collaboration. Multiple programming languages are supported, including Java and Python. Cucumber is widely recognized and used. BDD uses a domain-specific language to describe behavior. DSL is structured yet readable, bridging business and technical understanding. Features, scenarios, and steps are organized logically. This structure makes behavior easy to follow and understand. DSL is not a full programming language. Gherkin is a formalized language for writing BDD scenarios. It uses keywords like given, when, and then. These keywords make scenarios clear and testable. Gherkin ensures scenarios are machine-readable and consistent. It supports traceability from requirement to automated test. BDD becomes powerful when integrated with automation tools. Tools like Selenium and Cypress perform real actions on software. Selenium automates web browser actions like clicking buttons. Cypress is used for modern web applications with fast execution. Integration turns behavior descriptions into executable tests. A successful BDD process starts with identifying requirements. Behavior is described using Gherkin keywords. Step definitions connect scenarios to real code. Automation tools execute steps against the software. Results compare actual behavior to expected outcomes. BDD improves collaboration among stakeholders. It reduces misunderstandings and aligns software with business needs. Test scenarios become readable and maintainable. Automation supports regression testing and boosts software quality. BDD fosters confidence in software releases. BDD can be time-consuming initially due to scenario writing. Poorly written scenarios lead to vagueness. Good communication between stakeholders is essential. Strong automation support is needed for effectiveness. BDD is not a shortcut and requires discipline. A BDD plan was executed for a user login web application. The application allows login with valid credentials. Incorrect details trigger error messages. Scenarios were written in Gherkin and tested with Selenium. The plan demonstrated BDD's effectiveness in validating software behavior. The login system requires valid credentials to access the dashboard. Incorrect details prompt error messages. Blank fields prevent login and show validation messages. These requirements were converted into BDD scenarios. The scenarios defined expected behavior for testing. Cucumber, Gherkin, and Selenium were used for the BDD plan. Cucumber allows writing readable feature files. Gherkin provides structured syntax for scenarios. Selenium automates browser actions for testing. These tools are suitable for web application testing. Key scenarios included successful login with valid credentials. Failed login with an invalid password was tested. Blank fields triggered validation messages. These scenarios ensured normal and validation behavior was tested. The BDD plan focused on these key scenarios. The BDD feature file was written using Gherkin syntax. It included scenarios for various login outcomes. Keywords like given, when, then, and were used. The structure made behavior readable and traceable. Step definitions linked scenarios to automation code. Step definitions connect BDD scenarios to executable actions. They automate actions like opening a page or clicking a button. Selenium was used to implement these definitions. This connection turns readable behavior into executable tests. It ensures scenarios are directly linked to real actions. The BDD plan was executed against the application. Successful login redirected users to the dashboard. Invalid password displayed error messages. Blank fields showed validation messages. All scenarios passed, confirming expected behavior. The BDD plan effectively validated user-facing behavior. It linked business requirements to automated testing. Scenarios were clear and reduced ambiguity. The plan supported repeatable and maintainable tests. However, it did not cover all edge cases or performance aspects. The BDD plan was robust for expected user behavior. It identified visible mismatches in expected outcomes. However, it lacked coverage for security and performance testing. It was not comprehensive enough for all technical issues. Broader testing is needed for full robustness. Performance levels were not deeply tested in the BDD plan. Response times and load handling were not measured. Basic responsiveness was observed during execution. More formal performance testing is needed. Tools like JMeter could provide deeper insights. The BDD outcomes matched expected behavior for tested scenarios. The results were reliable and repeatable. However, the scenario set was limited. Broader testing could reveal additional unexpected behaviors. The outcomes were strong but not exhaustive. The BDD plan was effective for validating key user behaviors. It provided clear, testable specifications and supported automation. However, it was not comprehensive enough for full application robustness. Broader testing is needed to cover all edge cases and performance aspects. However, additional tests are needed for full robustness. BDD effectively defines, automates, and validates software behavior. This is the conclusion of the video. Feel free to send a WhatsApp message to 0748-436-1688 if you need assistance. Our team is here to help. Thank you for your attention, and we'll see you next time.